Okay, let's practice one more question of a very similar kind. So this time again we are given the revenue and the cost function, and we are again given a domain, and we have to find the break-even point. So the domain is that x should be between 0 and 125. Revenue is this, cost is this. So let's set them equal to each other again. So I'm again going to take revenue and set it equal to cost, and then solve for x. So we get 500x minus 2x squared equals negative x squared plus 270x plus 5125. So again, collect all the terms on one side, and when we do that, we get x squared minus 230x plus 5125 equals 0. So what I basically did was bring everything to one side. So collect on one side. You all can do this. Now when we look at this, the factors are not very obvious. So maybe this time round we should try using the formula. Some of you may see factors. If you do, great. If not, formula always works. So let's practice. So clearly A is 1, B is negative 230, and C is 5125. So let's go substitute in our good old formula. Negative B plus minus B squared minus 4AC over 2A. So when we substitute, we are going to get negative of negative 230 plus minus radical negative 230 squared minus 4 times 1 times 5125. Pretty long one. Divided by 2 times 1. So obviously now you can take out your calculators, and when you do it, you're going to get 230 plus minus radical 32400 divided by 2, and that turns out to be 230 plus minus 180 over 2. So we have two answers. X could be 25 or X could be 205. Now again, remember that the domain is between 0 and 125. So this one is okay, but this one cannot be. So therefore, the final answer would be the break-even point is X equals 25. So to put it all together, as you would have noticed in the previous two questions, it basically comes down to solving a quadratic equation, and we had practiced this many times earlier, and you should be able to do it. Now we move on to the second application, and that is the supply and demand problems where the functions are now quadratic. So just as in the previous section, our supply as well as demand both were straight lines. If you remember, this was the demand and this was the supply, and we were interested in finding the equilibrium point. This time we could have either both or one of them to be quadratic. So for example, if your supply is quadratic, so suppose the supply is a parabola like this and demand is a line like this, we may want to find the equilibrium point, which would be the intersection of these two. So that's exactly the case here. Our supply is this equation and the demand is given by this. So the first question is, what is the equilibrium quantity and price? So we are going to set these two equations equal to each other. So that means q squared plus 200, which came from here, has to be equal to this guy, which is negative 10q plus 3200. Again, bring everything to one side. So suppose I bring everything to this side, I would get q squared plus 10q minus 3000 equals 0. Now again we have to solve. So as I've been repeating many times, either you can factor if you see it, else you could always use the formula to do it. So this time the factoring seems to be pretty easy. So the factors would be q plus 60 times q minus 50, because 60 times negative 50 would give you negative 3000, and adding 60 and negative 50 gives you 10, so it works out. So this factor tells me that q could be negative 60. This factor tells me that q is 50. Obviously quantities cannot be negative, so this solution is not possible, whereas this seems to be correct. So my equilibrium quantity would be 50 units. 50 units. Now I have to find the equilibrium price. That you can always find by using either one of those two equations. So it's your choice, whichever one. Suppose I want to use this guy. So I know price is q squared plus 200, but then q is 50, so that means 50 squared plus 200. So that means 2500 plus 200. So that is $2700. So this is my equilibrium price. Finally, the question asks, graph the supply and the demand function. So in this particular case, we have to graph each one of them. So let's look at the shape. We don't have to graph exactly, but have a good idea what it is. So if I look at the supply, that is quadratic. Remember that this axis is Q and this is P. So this is like Y and this is like X for us. So if I were to graph P equals Q squared plus 200, then it would be a parabola facing up and would look something like this. You could easily find the y-intercept, and that is 200. So this is my supply, and the demand is simply P equals negative 10Q plus 3200. So this is a negative slope, and y-intercept is 3200, so it would be a line that goes like this. So obviously this side of the supply does not make any sense. I'm just graphing it, but you need not really look at this side. It's only on the positive side it makes sense. Similarly, so this is the supply and this is the demand. And what we just found earlier was this point. So Q, this was 50 units and the price was $2,700. So these are the applications of quadratic functions, type 2 applications, where revenue and cost functions were quadratic and where the supply and demand functions were quadratic.